Okay everyone, so I'm going to continue with the transcendental functions here. I'm just going to copy and paste this thing so that it's easier for you guys to see. I don't know if this is large enough. Now these things are complicated, okay? But you can also see that there's a pattern. For example, the difference from the arc sine to the arc cosine, the derivative of the arc sine to the derivative of the arc cosine is just that it becomes from a positive to a negative, right? The arctangent to the arc cotangent is just a positive to a negative, and the arc secant to the arc cosecant is just also from a positive to a negative. I'm going to prove the first formula here. Yeah, the derivative of the arc sine in one way. I'm going to prove the derivative of the arc cosine in another way. All right. So you have the arc sine in there. Now, what's the derivative of the arc sine? Well, let's just say that, remember, what we want is the derivative of the arc sine, right? I'm going to put just this in here. And I'm going to put an x instead of a u, but I'm going to replace it for a u later. It's very simple. So I'm going to put an x in here just to... remember that when you have a function, okay, so you have a function, the derivative of this function is going to be equal to the reciprocal of the derivative of the function's inverse, like f inverse, the derivative, okay, of what? Of this function here of x. So it'll be the f of x, okay? I don't know if you remember this theorem. It was from a few classes behind, a few classes previously from this one. So you have the derivative of this is going to be equal to the derivative of the sine. Okay, now what is the derivative of the sine? It's the cosine. So it's the cosine of what? The cosine of this function itself, arc sine of x. All right, this is the theorem. Okay. Now you see what the cosine is. Remember that identity that the cosine squared plus the sine squared equals 1? So the cosine equals the square root of 1 minus the sine squared, right? So I'm going to copy, I'm just going to say an equal, okay? So you have 1 divided by the square root, I'm going to make a huge square root in here to fit, of 1 minus the cosine. It'll be the square root of 1 minus the sine squared, right? Of what? Of whatever is inside the cosine, which is arc sine of x. Well, the sine of the arc sine of x is just x, right? Because it's a composite function where the outer function is the inverse of the inner function, or vice versa. So the sine of the arc sine of x is x. The sine squared of the arc sine of x is x squared. So this equals 1 divided by the square root of 1 minus x squared. Okay, so that's the derivative of the arc sine. Now, which is right here. Oh, but there's a u in there. Well, okay, let's just say that instead of the arc sine of x, you have a function of x. You have some kind of function of x instead of x, which is x squared plus blah, 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 right? So we're going to call this function of x u. So instead of an x in here, okay, it's just going to be a u. I'm just going to erase all these things. Here we go. There. And there. So instead of x, you're just going to put a u here, a u here, a u here, and a u here, right? It's going to be a u squared, u. But because you have to derive this thing here with respect to u, and then u with respect to x, because u is a function of x, you have to multiply by du, right? So 1 times du is just du. So there you go. Du is the same thing as u prime, okay? That's why you have this here. Look at this formula and look at this formula. They're the same, right? Now, I'm going to prove the arc cosine using a different method. But either one of the methods can be used to prove any of these. So the arc cosine, okay, so we can say that y equals the arc cosine. I'm just going to say of x, okay? So you have that. Well, let's check the cosine of both sides. The cosine of y equals the cosine of the arc cosine of x equals x. There you go, right? And now you want to take the derivative of what you want is y prime, right? The derivative of the arc cosine. Well, you take the derivative of both sides in here, so it's going to be minus sine of y dy, because y is a function of x, right? So you have to multiply this by dy dx. I'm just going to say this is y prime equals 1, okay? So here you have y prime equals minus 1 divided by the minus, it's minus divided by the sine of y, okay? And the sine of y is going to be the arc cosine of x, right? But what is the sine? Here we go again. We're going to do y prime equals minus 1 divided by the square root. What is the sine? Okay, is the square root of 1 minus the cosine squared. This is the sine of what? Of the arc cosine of y, right? But y is the arc cosine, so you put an arc cosine of x in here. So this is going to be equal to minus 1 divided by the square root of 1 minus x, because it's the cosine squared of the arc cosine. So it's just 1 squared. I forgot the square. So you can see in here it's a positive, in here it's a negative. In here it's a positive, in here it's a negative, in here it's a positive, in here it's a negative. Now I know these things are very hard to memorize, so, but anyway, before we go into any exercises, I want to show something else that the book shows. I want to show this thing here. I'm gonna get it as much as I can. I want you guys to see something. Let's just say that instead of being an arc sine of u, is an arc sine of u divided by a, okay? Let's just do the inverse, okay? I know it's showing the integral here, but let's just show the derivative by doing the inverse. So you know that instead of being a 1 here, okay, you actually have an a squared. So the derivative of the arc sine of u divided by a is du, right? Divided by the square root of a squared minus u squared. When it comes to the tangent, to the arctangent and the arcsecant, you know that there's a little bit of a difference. You see this 1 divided by a here and this 1 divided by a here? Well, it's not here. Where's the 1 divided by a here? So the arcsine has this difference between the arccosine, the arctangent and the arcsecant. Okay. When it comes to the arccosine, the arcotangent, the arcosecant, all you gotta do is to use a negative sign. But the arcsine is different from the arctangent and the arcsecant because it doesn't need this 1 divided by a. Okay, the arcsine of u divided by a is du divided by the square root of a squared minus u squared. Now, when it comes to the tangents, not just the arctangent, right, of u divided by a, you have to have this 1 divided by a times the arctangent and u divided by a. You take the derivative of all this, and you're going to come up with du divided by a squared plus u squared. There's also something else that I want to show you. The arcsecant is the same thing. You have to have the 1 divided by a. So when you're integrating, the result of the integration has to put this u in absolute value. When you're differentiating the result, so it's always in the result. The result here has to be also an absolute value. Okay. And if you want to find out why, all you got to do is to take, I'm not going to prove all of these, but for example, I want to know the arcsecant. Well, you can use that thing. You can use that method. Let's just say that f inverse equals j, right? So the j derivative equals the 1 divided by the derivative of f of what? Of g of x. You can do this, or you can just take, for example, I want to find out the derivative of the arcsecant. So take the secant of both sides, right? It's going to be y equals the arc. You know what? Instead of saying arc, I'm just going to say secant, inverse. Okay? So you take the secant of everything of y. This is going to be of x, right? Well, the secant of the arcsecant is just x. And you just keep going, differentiate this with respect to y and multiply by dy dx, and this one you're just going to multiply by dx, so it's just going to be 1 in here, right? And you keep going and you're going to find out that you find these formulas. Now, I know it's a lot to memorize. Even I'm having a hard time memorizing all this thing. So let me see here. Let's try a few exercises. Y equals sine inverse of x plus x square root of 1 minus x squared. You want to differentiate this with respect to x. Okay? So you're going to differentiate that. Okay, I'm not going to do this. I'm just going to say y prime. So this is x, right? It's going to be 1 divided by the square root of 1 minus x squared. Okay? 1 divided by the square root of 1 minus x squared plus. And then you do this here. I'm going to use the product differentiation formula. I'm going to differentiate the first one times the second one plus the first one times the differentiation of the second one, which is what? It's times half, right? Times 1 minus x squared to the minus half. Or I can just put square root of 1 minus x squared times the derivative of this, which is minus 2x. So times minus 2x. Okay, so this 2 and this 2 cancel, and this becomes now I'm just going to copy this over here. I'm going to put this equals in there, and this is actually going to become a minus. It's a minus x squared over square root 1 minus x squared. Okay, now let's see. If we take the minimum common denominator, so we're going to put a square root 1 minus x squared here, and I'm just going to delete this square root in here. Okay? Because that's what happens. So you see you have 1 plus 1, which is 2, minus x squared, which is minus 2x squared. So this whole thing is going to be like 2, 1 minus x squared divided by the square root of 1 minus x squared. Okay? Which is the same thing as 2 square root of 1 minus x squared. Why? Because here you have a 1, and this is the same thing as 1 minus x squared to the half. So 1 minus half is half, so that's what you have in here. Okay? So you can see that the integral of Why are they showing this? I want to explain why the book is showing this. The integral of 1 minus x squared dx. Why is the book showing this? Well, this is going to be because the integral of two of these is going to be this, okay? The integral of just one of this is going to be this stuff in here. Going to be this stuff in here divided by 2. And why is the book showing this? It's because, you see, sometimes you're going to have to do a few things. For example, what is 1 minus x squared? You can say that this equals the y value of a circle centered at the origin with a radius of 1. So when you have a circle, okay, it's x squared centered at the origin with a radius of 1. Remember that here you have the radius squared. This is the equation of the circle. A 1 squared is just going to be 1. So what is y? Y equals the square root of 1 minus x squared. Okay? When you try to integrate this stuff, it doesn't really work. You actually have to express x as a function of theta and y as a function of theta and differentiate and integrate the whole thing with respect to theta. Why? Because you see, for example, let's just say that you're integrating from 0 whatever to, let's see, r, and you're integrating this stuff, okay? So it's 1 minus x squared to the half. So what's this going to be equal to? Well, it's going to be equal to 2/3, right? 1 minus x squared to the 3/2, and then you have to divide this by the derivative of this stuff, which is minus 2x. So you get this thing out of here, you put a minus here, and you say minus 6x. Now, here's the thing. You're integrating from 0 to r, right? I'm going to delete this thing here, like that, and do this, and you do this from 0 to r. Try to replace the 0 in here. What's going to happen? In here is just going to be 0 squared. Doesn't really matter. But in here, you're going to have a 0. So this is going to be a non-zero divided by 0, which doesn't exist. And if it's approaching 0 from the right, it'll go to infinity. And if it's approaching 0 from the left, it'll go to minus infinity. So it just doesn't work. But you need these things sometimes. Okay, sometimes you need this stuff to, for example, to find out through calculus the area of a circle, the volume of a sphere. No, not the volume of a sphere, but the area of a circle. Yeah, stuff like that. You're going to need this, but you can't integrate this stuff. Well, now you can because you have this thing. Okay, so you know that the integral of this is going to be the inverse sine of x plus x, the square root of 1 minus x squared divided by 2. But you don't have to memorize this formula because either way, all you got to do is express it in terms of theta. You say that x equals r cosine of theta, right? And y equals r sine of theta. And then you do dx and dy. And you're going to change the dx, or if you're integrating with respect to x, you're going to change the dx to d theta. And if you're integrating with respect to y, you're going to change the dy to d theta. So I'm just trying to share some experiences that I had in my personal life, messing with mathematics with you guys. Okay. Now, something interesting here. It says y equals, well, it's just asking to derive. Okay, whatever. Arc tangent of x, and the arc tangent is squared. Okay, so y complement is just going to be 2 times arc tangent of x, right, times the inner function, which is the arc tangent of x. So it's going to be times 1, right, divided by 1 plus x squared. Now, you see, that's the first derivative. So let's analyze this thing. If you First, you got to equate this thing to 0, right? So we can find the relative or the global maximum and minimum, or the maxima and minima. So how can you get a 0 in here? The denominator has to be different than 0, and the numerator has to be 0. Well, what value is the arctangent is going to spit out a value of 0 degrees, okay? So what value, not value of a degree. I'm not talking about a degree, I'm just talking about a scalar. What scalar do you have to give an arctangent to get a degree of 0? Well, the tangent of 0 is 0, so the arctangent of 0 is also 0, right? The tangent of 0 degrees is 0, so the arctangent of this is going to be 0 degrees. So the only thing that's going to make this thing here is 0. You can also have the arctangent of oh no, yeah, that's right. That's it, guys. The only thing that's going to make this thing 0 is when the x is 0. Okay, this is going to be 0 degrees when the x is 0. Okay, so going a little bit to the left, okay, let's just say that we're going a little bit to the left, something negative like -½ or something, because all right. So when x is 0, okay, okay, something to the left, something over here. Well, whatever is negative in here is going to become positive because it's squared. So the denominator is always going to be positive. Now, if you're like this, guys, okay, this is the tangent. This is going to be the unit circle, okay? It's just that I'm in a hurry to teach this to you guys. That's why I'm doing these things all messed up. So this is the tangent line. So the tangent is going to be 0 here, blah, blah, blah. Now I want something, I'm going to give something negative, okay, some negative value in here. What is this going to be equal to? It's going to become a negative value, right? It'll become a negative, how can I say? It'll be a negative angle here, okay? So this is a negative and this is a positive. The whole thing is going to be negative. So you know that to the left of this, okay, the slope is going to be negative. So you want something like that, something, okay? Okay, what about to the right? Well, if it's in the right, some value over here, it'll be positive, the angle will be positive, positive divided by positive is positive. So to the right of the value 0, the slope is positive like this, right? Now when you check the second, so you know that this is a minimum, right? When you check the second derivative, I'm not gonna do the whole thing here, okay? When you take the second derivative, you're gonna come up with this. Because to take the second derivative, guys, you gotta use the division rule, right? The second derivative is gonna be 1 plus x squared times the derivative of 2 arctangent of x minus the 2 arctangent of x times the derivative of 1 plus x squared divided by 1 plus x squared squared, okay? But I'm not gonna do that. Anyway, I'm just going to give you the value ready, so we don't waste any time. 1 minus 2x arctangent of x divided by 1 plus x squared squared. So let me see if I copied this right. Yes, I did. Okay. Well, you see, the only way that this is going to be 0, because over here is never going to be 0 because of this 1 here, okay? This is never going to be 0. So the only way that this can be 0 is if 2x, the tangent inverse of x, This is a big X. Man, what a mess. Jesus. Okay. 2x, the tangent inverse of x equals to 1. Okay. Because you're going to plug this in here and it's going to become 1. 1 minus 1 is equal to 0. All right. Now, so you see that you're going to have tangents everywhere. Okay. Maybe the way to isolate the x in here, I don't know if it's possible. It's going to be x, and then I'm going to put the equal sign in here. I'm going to put the 2 down there, and then I'm going to say that I'm going to multiply this thing here. Oh, no. Yeah, by the tangent. Well, no, I can't do that. Right? I would have to put the x over here, and I'm going to have to put the tangent inverse of x in here. Okay, and then I'm just going to take the tangent of both sides, take the tangent of this and take the tangent of that, but then you're going to have a tangent of 2x in here, so it's kind of complicated. The book just try to guess, okay, to find whatever makes, for example, instead of being an equal here, you're going to put a minus here, minus, and this equals 0. Forget about this. So you have 2x times the inverse tangent of x minus 1 equals 0. And you have to find the root, okay, whatever this becomes 0. Well, the book just found that stuff using Newton's method. And I don't know if you remember Newton's method. Newton's method means that if you have a guess, okay, of an x and y coordinate in the Cartesian plane, so you're going to have some x0 and some y0, okay? And the whole thing is going to be like, the new x, like x1, is going to be equal to x0, right? And then you have minus, I think it's f of x0 divided by this. Yeah. If I'm not making a mistake, that's it. Because this is going to be like the x, okay? This is like the point slope equation. So it's like y minus y0 equals mx minus x0, right? So if you make this thing 0, what do you have? You have minus y0 equals mx minus mx0, okay? And then if you want to isolate the x, you're going to say that x equals, and then you have I don't know if this is the right thing to do. Yeah, minus y mx minus mx0. So x is going to be equal to mx0, right, minus y0, yeah, divided by m, so this m goes away and you got an m here. Yeah, so, right, this is right. Okay, so the x0 is x0 here, okay. The y0 is going to be the f of x0, it's here, the negative sign, and you have a slope here where? You have a slope at, because this is a straight line formula, the tangent's never going to change, but here the tangent changes. So it'll be the f prime of x0. So using this method here, the book was able to find that x, okay, the x that makes this true is going to be plus or minus 0, approximately, okay? 0.765. What I'm guessing, guys, is that a computer found this stuff, okay? They plugged in this equation here, and the computer tried it by trial and error. Okay, so we're going to start with this point, for example, x0, y0, and then we're going to try to find the root through Newton's method using this formula. Oh, but it didn't work. Okay, so we're going to try x1, y1. Let's try something else. And then use this formula again, but this time on x1, okay, to find y1, blah, 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 using, x1 and y1 to find x2. But the computer was able to find these things plus or minus 0.765, okay? So what does this mean? It means the second derivative, this is the value that's going to make the second derivative become 0, okay? Now, if the second derivative becomes 0, that means that's a point of inflection. I don't know if you remember that a long time ago, when you have the first derivative equals to 0 and the second derivative is positive, you're going to have concavity up. If the second derivative is negative, you're going to have concavity down. If you have the first derivative different than 0 and the second derivative equal to 0, that's the point of inflection. So let's just say that this is 1, okay, and this is minus 1. So around here, the thing is going to do like this, okay? The concavity from going negative, well, it's still going to be negative, but instead of being concavity up, it'll start going concavity down like that. And the same thing is going to happen over here. It'll change to concavity down and it'll keep going, okay? So it'll keep going like that. All right, it's going to approach a line in here, a horizontal line in here. What is this horizontal line? This horizontal line, well, let's think about the original formula again, okay? As x goes to infinity, let's think about that ball, that thing, that's that circle, and a straight line, which is a tangent here. It's a vertical line, okay? So you want to, as x goes to infinity, I'm talking about what angle is it going to be when the values are reaching infinity like this? Where they're reaching infinity, the angle is going to be pi divided by 2, okay? So as this is the graph of this function. As x goes to infinity, what is the value that this function is going to get? Well, as x goes to infinity, the angle is going to be pi divided by 2, but it's squared. Okay, so as x goes to infinity, this thing here, y will approach pi divided by 2, but it's squared. So it's pi squared divided by 4. So this is the value of y equals pi squared divided by 4. The exercise is asking us to analyze the graph of this. That's why I'm doing all this convoluted thing, okay? And I'm going to show you the graph now. There. You see that? Okay. So here you have the pi squared divided by 4, okay? And here you have the 0, 0. Here you have this stuff in here. It's going to be 0.765 for x. And this one in here is going to be minus 0.765 for x. Okay? And that's when it starts from concavity up to concavity down. You see? This thing is going to keep going till it goes like this. But it's never going to go like this, okay? It's going to approach this line here forever. But if you were a concavity, yes, it's concavity down. From here on out, it's concavity down here, and it's concavity up in this bowl here, okay? And that's it, guys. I think that's it for this video. I don't want to make I don't want to make videos that are too long. Yeah. I was just thinking about another way of saying this, like, I don't want to make too long of a video. Yeah. All right, guys. See ya.